Welcome back. This is going to be the second video about 4-4. Thomas, my friend, has agreed to be in the video today. But the last thing I did in the previous video was I wrote this third law of logarithms up here. And I was saying how great this law of logarithms is. And Teddy, I want to pose a question to you. Okay? So,
Vacuum cleaner.
do you recognize that as a 9? I'll write it.
Yeah, that was a 9. So do all the animatronics. They all think it was a 9.
So I wrote an equation there. 3 to the x power equals 9. Now, Teddy,
What's the x?
well, that means it's an unknown. So this is an equation, right? And you know what an equation means, right? The value on this
Yes.
side has to equal the value on this side.
Yes.
and-
Stop
and
shaking,
then-
Freddy.
Then hey, Teddy, here's what I want you to think about. Can you think of a number that I could put in there in place of x that would make this equation true?
2.
Yeah, good, because 3 to the second power equals 9. That's very good. But now, let me change one thing
Bonnie
about
made
this
up the
equation.
idea.
What?
Bonnie made up the idea.
Okay. Let me change that just a second and put, instead of a 9, put an 8 here. Okay. Now, Teddy, can you think of a value of x that would make that equation true?
No.
Yeah, I can't either. I mean,
No.
2 would be too big, right? 2 would be too big, and 1 would be too small, because 3 to the first power is 3, 3 to the second power is 9. So, how do we solve an equation like this? Well, the answer is we can solve it with logarithms. I'm not actually going to solve it right this second, but I promise I will solve that exact equation here in just 1 second. Actually, you know what? Let's just go ahead and solve it right now. If you remember from the previous section, 4-3, does everybody remember, hopefully, what this means? Okay, ln. Remember, that means natural logarithm, which is a logarithm with base e. Okay, Teddy, we better be able to see this screen.
You can see all of it.
Alright, now, and so this is just a log with a base of e. And the only reason I'm going to use a log with base e to solve this equation is because we have a log base e button on our calculator. We have a natural logarithm button on our calculator. So what I'm going to do is I am actually going to I'm going to perform the same operation on both sides of this equation. And the operation I'm going to perform is I'm going to take the natural logarithm of each side. So what I'll do is I'll take the natural log of the left side, and I'll also take the natural logarithm of the right side. I kind of have to squeeze it in there if I didn't leave much space. Now, what in the world good does that do? Well, if we look at your notes, I know I erased it, at law 3, okay? Law 3, the third law of logarithms, which says that if I have a log of an expression raised to an exponent, I can move that exponent out in front. Okay, so I can rewrite this as x times natural log 3 equals natural log 8. Okay. Well, that x is no longer in the exponent. That's kind of a bonus. I think that all I'd have to do now to get x by itself, to isolate x, this is just x times natural log 3. Well, to undo multiplication by log 3, I'll just divide both sides by natural log 3, like so. I'll just divide by natural log 3 here, divide by natural log 3 there, and I get x equals natural log 8 divided by natural log 3. And that is the exact answer, okay, to that equation. That's the exact value of the solution to that equation. And it's in simplest form as well. Okay, so if we wanted an exact answer to that original equation, 3 to the x power equals 8, there it is. Now, if on the other hand we wanted a decimal approximation, this is where I would take a calculator and I just enter this. I just enter this expression. Natural log 8 divided by natural log 3, hit enter, and it would give you the decimal approximation to the solution to that equation. You could round it to whatever decimal place was specified. Okay, so here's what I want you to realize. What I just did was I used that third law of logarithms to solve an equation where there was a variable in the exponent. Okay, from this day forward, okay, in your lives, whenever you're trying to solve an equation, and there's a variable in an exponent somewhere, you're going to need to use a logarithm to get that variable down out of the exponent. It's kind of traditional and just as easy as anything to use natural logs, but of course you're free. Log base 10 would be the other logical choice because you have a log base 10 button on your calculator as well. Okay, now let's now look at maybe an example. I wrote down that I'm going to do problem 11. This is going to be my version of problem 11 out of the assignment. And let me write the expression that they have given to us.
At the end of this video, I am telling the tea cart story.
Okay.
Or you will.
This is the expression that they have given us. And the instructions, I mean, you're welcome to pause the video and go to your WebAssign and do your problem along with me. But the instructions here, it says use the laws of logarithms to expand the expression. Okay, so this whole expression has just one single logarithm in it right now. The log of this whole rational expression there. And what we're going to do is we're going to use the laws of logarithms to expand this. Now, the very first thing I notice is this is the log of a quotient. Okay, the numerator is 3x to the 9th, the denominator is that quantity to the 7th power. So since this is the log of a quotient, I know that one thing that I can do is I can rewrite this as the difference of two logarithms. I can write it as the logarithm of the numerator minus the logarithm of the denominator. Like so. Now, I have expanded that expression, not completely yet, but this is, I now have two logarithms in my expression where at one time I only had one. Well, okay, let's see what else we can accomplish here. I notice this expression right here. This is the log of a product. This is the log of the product of 3 and x to the 9th. This is 3 times x to the 9th. I'll warn you against trying to use that third law just yet. By the way, the third law of logarithms is called the power law. I think I never really actually used that phrase when I was talking about it. But since the only thing that's being raised to the 9th power is the x, the 3x is not, that 3 is not part of the expression that's being raised to the 9th power. So I can't just bring that 9 out front using the power law. What I'm going to have to do is I'm going to have to use the product law. So since this is the log of a product, I can rewrite this as the log of the first factor plus the log of the second factor. And then over here, well, I have the log of an expression, and the expression being the x plus 4 raised to the 7th power. So I am going to use the third law. I'm going to use the power law down here, or over here in the second term of the expression, to write this as the 7 times the log of x plus 4. Okay, now, can I do anything else? Well, you can look at it for a second and see what you think. This term is obviously simplified completely, natural log 3. Now this term, I can use one more law, right? I can use that third law now to bring the 9 out front since this is just the log of x to the 9th power. So I'm going to write this as log 3 plus 9 log x. And then over here, now, do not be tempted to distribute the logarithm. This is not natural log times the expression x plus 4. This is the natural log of the expression x plus 4. And unlike multiplication, the operation called logarithm is not distributive. Okay, I can't use the distributive property here because that is not a times sign between the natural log and the quantity x plus 4. So this is actually simplified as well as it can be. Expanded as well as it can be. I don't see any more laws of logarithms that I can use to expand that further. So we're going to call this complete. Teddy, how are we doing time-wise?
10 minutes.
I'm so glad to hear that. Alright. And I wanted to do one more example. I did an example there of how to use the laws of logarithms to expand an expression. Now I'm going to use do an example of how to use the law of logarithms to condense the laws of logarithms to condense an expression. So I'm doing number 12. So I'm going to write log of 10 plus 1/2 log 2 minus log 2. Okay. Now one thing you notice right away is those logarithms, none of those logarithmic expressions have visible bases. Okay, we all know from lesson 4-3, remember that means that they are all base 10. Okay. Now, if these logarithms have different bases, like if this was base 2 and this was base 3 and stuff, I can't use the laws of logarithms in a case like that. But here, if you look, I do have 3 terms in my expression, and all 3 of them have a logarithm in them. Now, before I just go crazy with things here, I'm going to notice something here. I can't use laws 1 or 2 as long as there's a coefficient on one of the logarithmic expressions for which I'm trying to use those laws. So what I'm going to do is I'm immediately going to drop down the line and move that 1/2 up into the exponent there. I'm going to write this as log 10 plus log 2 to the 1/2 power minus log 2. Okay, wonderful, wonderful. Now, from there, it looks like I can, I have the sum of 2 logarithms here, and then I'm subtracting this final logarithm. Now look, I'm going to use both log 1, I'm going to use log 1 to condense these 2 terms into one logarithmic expression. But at the same time, I'm going to use log 2 to involve this one as well, because these are going to come together to make a single logarithm. And then remember that, so it'll be a logarithm minus another logarithm, which means I can rewrite it as log of the quotient. So this is going to be the log of, I'm going to open a quantity here, 10 times 2 to the 1/2. Now, I'll just put times and then like so, and then divided by 2. Okay. Now, this is, reasonable here. What I'm probably going to do, though, is simplify this. I've condensed it into one logarithm, which is kind of the original idea here. But now I notice I've got a 10 up here and a 2 down there. 10 divided by 2 is 5. So I'm going to rewrite this as log of 5. And then 2 to the 1/2, I'll just remember that's the same as the square root of 2. So that says log of the quantity 5 radical 2. That I think is going to pretty much do it. I think I talked about everything that I wanted to talk about. Feel free to email questions, take a picture of work, ask me to work through it and such. Thanks for watching. See you next time.